Today we're going to use subtraction to solve equations on a sentence mat. So in the last lesson, we used addition to solve equations. We used addition. We modeled this by putting tiles down on both sides of the equation. Putting tiles down on both sides of the equation until there were enough zero pairs to isolate the variable. Because addition is modeled by putting tiles down. Okay? And in the problems we did, sometimes x was part of a sum, like this equation where x plus 3 equals -5. So x was part of a sum because we were using addition. And sometimes x was part of a difference, like x minus 2 equals -7, because we use subtraction here. Both of these equations, we used addition to solve them, but both of these kinds of equations could be solved by using subtraction. But we would use, to model subtraction, that would be modeled by taking tiles away. From both sides of the equation. So we could solve all the same problems we solved in last lesson using subtraction by taking tiles away instead of putting tiles down. However, it is more common to rely on subtraction to solve equations where x is part of a sum. This is because addition and subtraction are inverse operations. We call them inverse operations. So they undo each other. They're opposite of each other, inverse. So adding is the opposite of subtraction. So if x is part of a sum, like up here with x plus 3, it's more common to use subtraction to undo that. So today we will use subtraction to solve equation where x is part of a sum. We're going to show our work algebraically and with algebra tiles. So yesterday we only worked with the algebra tiles, but today we're going to show our work algebraically as well. And we're going to continue like we did yesterday to check our solution with substitution. So we're going to keep doing this. So here's the first example. We're going to solve the equation below using subtraction. On the left, we're going to show how to model the equation and solution on the sentence mat. On the right, we're going to show each step you take algebraically. And in this box, we're going to show, we're going to check our work. Okay? So we've got this equation, x plus 3 equals 5. So the first thing we're going to do if we're solving with algebra tiles is we model it. X plus positive 3 equals positive 5. Now if we're solving algebraically, the first thing we write, algebraically just means using symbols. So we just write the equation, right? So this is how we model with algebra tiles. This is how we solve algebraically. Now, the next thing we want to do is we want to take away tiles, right? We're going to use subtraction. So here, again, just like yesterday, we say, where's the variable? Right here. How do we get it alone? Well, yesterday we tried to add things that made 0 pairs, right? Well, today we're just going to say, well, why don't I just take these 3 away? Just take them away. If I take them away, that uses subtraction. So the way I write that algebraically is on this side of the equation, right under the 3, I write -3. I'm taking 3 away from this side of the equation, and it's like I've got a little line down here, taking 3 away from this side of the equation. But look over here. This is unbalanced now. It was balanced, and I took 3 tiles away, so the scales are tipping. So what I do to one side, I need to do to the other. So I need to take 3 positive tiles away from this side. So so see, we kind of already know how to show that on the sentence mat, right? How we show that algebraically is we write -3 on this side, and on the other side of this equal sign, we write minus 3 right there. 5 and 3 are like terms, and 3 and 3 are like terms, so it makes sense to line them up. And now, what we write on this side, we see what's left. We see that it's x equals positive 2. And that same thing happens over here. If you notice, the 3 minus the 3, these go away. And what's left on this side is x. And on this side, the 5 minus 3 is 2, and what goes between is an equal sign. So see, whichever way you solve it, you still end up with x equals 2. You just have a nice picture over here of what's going on. So we solved it with algebra tiles, we solved it algebraically, and now we're going to check our work. Remember, checking our work just means taking our solution, substituting it back in where we see the x. So instead of writing x plus 3 equals 5, we're going to write 2 plus 3 equals 5. And we're going to ask ourselves, is that true? Does 2 plus 3 equal 5? Absolutely. So we know that we solved this correctly. One more example. We're doing the same thing. We're going to solve with algebra tiles and we're going to solve algebraically. We'll do them side by side. So the first thing we're going to do over here is model this. We've got 7 positive integer tiles on this side. And we've got -1 and an x tile on this side. But to write that algebraically is just to write 7 equals -1 plus x. Now, remember, we're solving by taking away instead of putting tiles down. So I want to take away this tile. I want to take away -1 from this side. But whatever I do to one side, I have to do to the other. I want to take away a -1 tile from over here too. It's just, I don't have a -1 tile to take away. So when you don't have enough to take away, that's when we have to add in a 0 pair on this side. Remember, adding a 0 pair will not change the balance. That does not change the balance. Now, taking that away has tipped it, but adding a 0 pair, this side is still worth 7 because 7 plus 0 is still 7. So we haven't changed this side. We haven't changed the value of this side. We've just changed the way it looks. So now that we've changed the way it looks, I took away a -1 from this side, and the scales are starting to tip, but I have a -1 to take away from this side too. So now the scales are still in balance because I've only done things that keep them in balance. I've added a 0 pair, and I've taken away the same kind of tile from both sides. Now, the way we represent that step over here is what we did to both sides was take away a -1, take away a -1. So I write minus -1 on this side, and I draw a little line down the middle. So minus -1, and I write minus -1 on this side of the equation. And now the last step is what's left. I have 1, 2, 3, 4, 5, 6, 7, 8 positive integer tiles on this side and an x on that side, so they're equal to each other. And if I look over here, see how I lined up my like terms? These are like terms, these are like terms. -1 minus a -1, that goes away. So all we have left on this side is an x. And 7 minus a -1, remember subtracting a negative is like adding a positive. So 7 plus 1 is 8. And we have the equal sign in the middle. So either way you do it, you are still coming up with x equals 8. And now we're going to check our work by plugging it in. So we write 7 equals -1 plus, and instead of writing the x, we put the 8 in to see if it works. Does 7 equal -1 plus 8? Yes, absolutely. So we know we did it correctly.